So last Friday we talked about converting phrases and words into algebraic formulas and sentences. Things like four times the difference of a number and 7. How would you write that? Careful. Remember, the difference is the result of a subtraction problem, which implies you must do the subtraction problem first and then multiply the result by 4. So how would I express that? Okay. So it's going to be 4 times a set of parentheses. What's going to be in the parentheses? X minus 7. Perfect. So the difference of a number and 7 is x minus 7. And then you're going to multiply that result by 4. So you have to put it in parentheses to tell whoever's looking at it that you're going to subtract first, then multiply by 4. Why do we have to have the parentheses? Well, because our order of operations says without them, you would have to multiply first and then subtract. So that parentheses is telling us in this case we subtract first. Bless you. How about this one? 7 times the number reduced by 3. There we go. There it is, 7 times the number. 7x reduced by 3, minus 3. So we have to multiply first here. We don't need parentheses or anything because order of operations tells us we would multiply before we subtract. So just order of operations forces that one to go in the order we want it to. We don't need parentheses to tell anybody what order that's going to happen. Well, the order of operations plays a big part in a lot of our basic algebra that we're going to be doing. So let's just take a look at an order of operations problem and see if you remember how to do them. Take a look at that one quick in your notes. I want you to try to do that problem. Okay, if you're skilled with your calculator, you can actually enter this in your calculator all at once and it'll figure it out for you. But I'm going to do it step by step by hand. What do we do first? Well, we see enclosing symbols is always first, and we work left to right. First one we hit is this one right here. Excuse me. This one right here. So we find its other end, and its other end is way down there. So working within that set of parentheses in that blue box, we see that there are other enclosing symbols. This one here, namely, and there's its other end. So we're going to narrow our focus to the green box. Inside there we see parentheses, but is that parentheses an enclosing symbol? Is there anything to do inside of it? In this case, it's not. All it is doing is separating the negative 5. I'm saying that's a negative 5, not minus 5. So we're working inside the green box. What do we have to do first? 1 times negative 5, which is negative 5. So then what's next? Add them. 6 plus negative 5 is 1. Everything else in there has not changed. So we can get rid of that parentheses and do 3 times 1, which is 3. Now we're out to the larger parentheses here. What do we do first in there? Powers, 2 to the 4th, which is 2 times 2 times 2 times 2. There's no 16. Then what? Powers and roots happen at the same time, but we're working left to right, so the square root of 16, which is 4. Any other exponents? Nope, no more powers or roots. So we're going to go back, and what do we do next? Multiplication and division, right? So 16 divided by 4, which is 4. Then what? 7 minus 4, which is 3. And then? Come on. Then we add 3 plus 3, which is 6. And 6 plus 4 makes 10. Now we don't need that set of parentheses anymore. So make that times 3 times 10. So 8 plus 3 times 10, what do I do next? 3 times 10 is 30. 8 plus 30 is 38. Anybody get 38? So something went wrong. Okay. Why am I reviewing the order of operations? Well, because today we're going to look at one of the other uses of a variable, which is a placeholder in a formula. If you are told to evaluate something, that means to give it a value. It could be as simple as this: 3x plus 5 for x equals 2. What that's telling you to do is replace x with 2 and then use order of operations to figure out what that value comes to. So 3x is going to be 3 times 2 plus 5. 3x means 3 times x. So you put the 2 in for x, it's 3 times 2. So now we have 3 times 2, which is 6, plus 5 is 11. Or it could be as complex as something like this. For a equals 6, b equals 5, d equals 3, f equals 18, and m equals 2. C equals 5, and p equals 7. So we have to replace every letter here with a symbol or with a number. Now I had a times b here, but I could have just wrote ab, which means what? The same thing, a times b. I put a times b in there just because it's one of our first problems and I didn't want to confuse you. But yes, if I just wrote ab and the same down here, if I just wrote cm, that means c times m. So let's put in the numbers. That's our first step, is to put the numbers in. So on top, a times b is going to be what? Well, a times b is going to be 6 times 5. We don't know yet if we can multiply them because we got to get everything in there and then look at our order of operations. Minus d squared is going to be 3 squared plus f over m is going to become 18 over 2. So on bottom, c times m is going to be 5 times m minus 7. So any questions on how I put the numbers in there? Now, of course, I said c times m could be just written as cm, but when I put in the numbers, I do have to put the multiplication in there. I have to put it in as 5 times 2. So now what am I going to do first? Now that I have the numbers in. The order of operations says that this fraction bar is telling me to start out by doing everything on top first. And up there I do have an exponent. 3 squared, which is 9. What's the next thing I have to do? Multiply and divide. So I got 6 times 5 is 30. 30 minus 9, and then I've got 18 divided by 2, which is 9. Now I have 30 minus 9, which is 21, plus 9, which is 30 again. So the top becomes 30. What do I have to do first on bottom? Multiply 5 times 2, which is 10. 10 minus 7. It's 3. So now I can divide. 30 divided by 3 is 10. So it all works out to a 10. What do y'all think? Good stuff? Still better than a sharp stick in the eye? So in your notes, I'm going to have you evaluate 7p minus qp squared plus 5m times n minus 3 for p equals 5, q equals 2, m equals 7, and n equals 10. So try that in your notes. So what do you guys get for answers on this? What's that? 230? Anything else? Let's take a peek. So this is going to become 7 times p becomes 7 times 5 minus qp squared is 2 times 5 squared plus 5m is 5 times 7 in the parentheses. N minus 3 is 10 minus 3. What do we have to do first? 10 minus 3, which is 7. We are now done in those parentheses. Now we do have to do the 5 squared, which is going to be 25. So now we're going to work left to right with our multiplication and division. 7 times 5 is 35. 2 times 25, 50. 5 times 7 is 35, times another 7 is 245. Careful. 35 minus 50 is a negative 15. Plus 245 is 230. So you were correct. Okay, so as you can see, we're going to run into negatives again. So I want just a quick review of negatives. 8 times the negative 4, what's that going to give us? Negative 32, yep. Negative 5 times 9. Negative 45. 8 plus a negative 17. Yeah, positive 8, negative 17 will be a negative 9. Negative 13 plus negative 4. Negative 17. Negative 4 minus 13. Negative 17. Good. Remember, you think of that one as being negative 4 plus a negative 13. Let's do negative 21 divided by a negative 3. Positive 7. Negative divided by negative is a positive. Negative 8 times negative 2. Positive 16. Negative 11 minus negative 6. Negative 5. Very good. That becomes a negative 11 plus a positive 6. So negative 11, positive 6. Perfect. Negative 5 to the power of 5. First of all, before you punch anything in, positive or negative? It's going to be negative. How do I know it's negative? It's an odd power, odd exponent. When I start with a negative, I can get either a positive or a negative result. If it's an odd exponent, it'll be negative. If it's an even exponent, it will be positive. So, negative 5 to the power of 5 should give you negative 15,625. Now, if you type that in your calculator and it tries to tell you, well, this one will be right. But let's do this. Let's do negative 7 to the power of 4.
I got 31,000.
For this one?
3,125.
Oh, yeah, you're right. That was the 6th I was going. 3125? Yeah. Thank you. That's much better. Negative 7 to the power of 4. $2,401? Positive 2,401. Anybody's calculator tried to tell you, you said negative, right? When you enter that in your calculator, you got to put the parentheses around it. Yep. Otherwise, your calculator does the power first, then puts the negative. That's an order of operations deal. Without punching this in your calculator, is that positive? Is that possible?
Yeah. No.
If you put the fourth root of negative 16 in your calculator, it's going to tell you no solution. So first thing you got to remember is how to put in the fourth root. You guys remember how to do that? For most of you, you got to put in the 4 first, then you got to do a second, then x root or n root, then type in the negative 16. It'll tell you no solution or error. Domain error usually it says. It can't do that. Can it do this? Yes, you will. It says negative 2, right? Why can it do this one and not this one? Yeah, it's a fifth root. Remember up here we said if we have an odd power, we'll get a negative answer. So this is saying what number to the power of 5? That's an odd power. So we can, if we start with a negative number, we can end up with a negative number. But we said when we have an even power, we will always have a positive answer, no matter what we start with. So here, to take the even root, this is saying what number to the power of 4 will be a negative 16? Well, since 4 is an even power, there is no number we can take to the 4th power to get a negative 16. Anything to the 4th power will be positive. So that must be no solution. So the moral of the story is we cannot do even roots of negatives, but we can do odd roots of negatives. In your big book, we're going to be looking at page 325 to 328, 1 through 17. And I'm also going to hand out a packet for you. Actually, you know what? No. For you guys, it's in your little book. Packets for the woods guys. In the little book, Unit 31.